project, which was to then actually work with Adam to get a National Science Foundation grant to actually design an instrument, a machine, to automate the grinding process. So what I just showed you is the automation of the reconstruction, digital reconstruction. This is an automation of the actual grinding. This is the machine we developed. It's basically a retrofit CNC surface grinder with an imaging station. And basically, we're really, you know, it's like our CNC machine, except it grinds things at 2.5 micron intervals, which is really insane. But this is the project we worked on. It took us about a year to do this. This is just a sample specimen. It shows you how it works. We ended up working with a couple folks up in Rochester who use grinders for a lot of metal work, and who know this stuff incredibly well, and people that do a lot of imaging for library science, documenting really high-resolution documentation of two-dimensional surfaces. So a very unlikely constellation of collaborators. What you can see here is, you saw it grinding. Here it's imaging. This is the camera. We ended up finding software that was off the shelf, which we were able to kind of appropriate, which was a voxel-based software, which is a kind of solid modeling software, which can also take things based on color and then create a three-dimensional model. So what you see here, we're moving through the specimen. In this case, these are ooids. And then can isolate areas of interest. And for Adam, what's also super important is then to run a battery of quantitative tests on this sample, so porosity, permeability, et cetera. And for us, it was an interesting project, but the software potentially holds interesting possibilities for design, I think, as well. It's not the kind of software that we typically use as architects. This is the machine. It's the centerpiece of a new lab at Princeton for the study of early animal life. But what's also really interesting